is that if she did what she said she was doing, she should have made it to another island.
Amelia Earhart and her navigator disappeared without a trace in 1937. The world was on the verge of witnessing an impossible feat. But a single radio transmission, lasting only a few seconds, ushered in 100 years of complete silence. The exact location of the plane and the events leading up to the disaster remain one of the most sought-after pieces of information in history. But all that is about to end. Decades of research have finally revealed what happened, and the truth will completely shatter everything we thought we knew before now.
One of the greatest mysteries in aviation history may finally be solved. For decades, explorers have been trying to find the wreckage of aviator Amelia Earhart, who was attempting to become the first female pilot to circle the world.
A historic circumnavigation. Before her disappearance became one of the world's greatest mysteries, Amelia Earhart was on the brink of making not just aviation history, but also exploratory, technological, and cultural history. She would become the first female pilot to make her way around the world in an aircraft. Members of the United States Army Air Service were the first to accomplish the feat in 1924. But like others who circumnavigated the world after them, they followed a northern route and flew close to land, finishing the journey in less than 27,000 miles. Amelia Earhart's attempt would see her attempt something no one had ever done before: travel more than 29,000 miles across 4 continents, while staying close to the equator. Her goal was simple in theory, but the execution was brutally difficult. It would test not only her navigation skills, but also her endurance and willpower. This attempt came with the ultimate challenge of flying across the Pacific Ocean. If you didn't skip your geography classes, you'd remember that the Pacific is a lot larger than the Atlantic. It is bigger than all of Earth's land combined. It is so massive that you'll see almost no land if you're looking at Earth from certain angles in space, just endless blue water stretching across nearly half the planet. For the final part of the trip, Earhart would pilot the plane from Lae, New Guinea, to the other side of the world. At the time, no plane could fly a distance that stretched. To increase her chances, a custom twin-engine Lockheed Electra was built for Earhart. They removed everything from the plane to make it lighter. That included insulation fittings that masked the sound from the engine. The result was an aircraft so noisy that she could only communicate with her navigator with a pen and paper, despite sitting beside each other. Lockheed also removed the passenger seats from the Electra and replaced them with fuel tanks. These efforts improved the plane's range to between 6,600 and 7,200 kilometers under excellent weather conditions. It was still insufficient to travel from Lae to Hawaii. The only solution was to stop somewhere in between for a refuel. That's where Howland Island comes into the equation. Howland Island is a small island located between Australia and Hawaii. The 2-by-1 kilometer island was so small and underdeveloped that it didn't have a runway. But even that was the least of Earhart's worries. Even if they managed to build runways on Howland Island, locating it would be like looking for a pin in a haystack. Yet on July 2, 1937, Earhart and her navigator, Fred Noonan, got inside the plane and set off towards the tiny island. It was the sort of risk only Earhart could take. And it was not her first rodeo either. She had already made history as the first woman to fly solo across the Atlantic. The History Maker. Born July 24, 1897, in Kansas, United States, Amelia Mary Earhart was the oldest of her parents' 2 daughters. Her adventurous spirit was evident from a young age. She often played outdoors with her sister, climbing trees, hunting small animals, and making houses for the much smaller ones, such as toads, worms, and moths. Her first flying experience came in December 1924. and the following month, she got herself a flying instructor with the money she earned from working multiple jobs. 6 months later, she bought her first aircraft and started breaking various flying records. Earhart set a world record for the highest altitude achieved by female pilots in October 1922. Less than a year later, she became the 16th female licensed pilot in the U.S. By 1928, Earhart secured her place in history as the first woman to cross the Atlantic by air. The feat was widely celebrated, and Earhart was treated to a hero's welcome in the U.S., alongside the rest of the flying team. The achievement granted Earhart a celebrity status. Putting her newfound fame to good use, she authored a book, went on tours, and landed roles and endorsements. But she wasn't going to rest on her laurels. On May 20th, 1932, Earhart flew a single-engine Lockheed Vega 5B from Newfoundland to Northern Ireland, becoming the first woman to fly solo non-stop across the Atlantic. She received national honors and medals and developed relationships with influential people. That included the First Lady, Eleanor Roosevelt. These connections made it easy for Earhart to convince the president to approve the construction of 3 runways on Howland Island by the time she was ready for her flight across the world in 1937. Howland Island fell under the administration of the U.S. after the Guano Islands Act of 1856. Earhart wrote to President Roosevelt saying, "Please forgive troublesome female flyer for whom this Howland Island project is key to world flight attempt." The journey and plans. With the runways constructed on Howland Island, Earhart began her journey around the world on May 20th, 1937, alongside her navigator, Fred Noonan. They went from Oakland, California, to Miami, Florida, before the official announcement on June 1st. From there, they departed from Miami in a twin-engine Lockheed Electra. For an entire month, everything went according to plan. They crossed South America, Africa, India, and Southeast Asia, until they reached Lae, New Guinea, on June 29. By now, they had covered 22,000 miles, and the remaining 7,000 miles were across the Pacific Ocean. The navigator, Fred Noonan, was in charge of calculating the flight plan using a method known as dead reckoning. It is a flight plan calculation method that considers airspeed, wind, and bearing to determine the time required to reach a destination. To autocorrect any error, they selected a position north or south of the island. This way, they'd know where to turn when the calculated time is reached. Noonan's calculations indicated that they would need to travel for 18 hours to reach the island, whereas the crew at Lae estimated the headwind to be 24 kilometers per hour. The first red flag appeared just 20 minutes into the trip. Lae radio operators tried to contact Earhart with a critical weather update. The headwinds were going to be much stronger than predicted. This wasn't minor information. The wind speed would determine how fast they fly and how long they had to go before making a turn to Howland Island. So, when Earhart never acknowledged or responded to the message, people started to worry. Now, there are 2 possibilities here. Either her radio wasn't working correctly, or she simply didn't hear the transmission. But the situation became more disturbing because this wasn't an isolated case. The radio silence was about to become a pattern that would define the next 18 hours and ultimately seal her fate. Meanwhile, they already suspected that dead reckoning wouldn't be enough to calculate their trip to Howland Island. Noonan, a licensed ship captain, was also experienced with another navigation system known as celestial navigation. This method could be used to pinpoint their location by measuring celestial bodies and comparing them to an almanac of 58 navigation stars. However, this method had already shown its limitations earlier in the journey. Minor errors in calculations caused them to miss their designated airport in Africa. Thankfully, they were able to land in other places. Since this wasn't possible on the Pacific, Earhart asked for 3 Coast Guard and U.S. Navy ships for communication and navigation support. The Ontario would be stationed in the middle of the route. The Itasca would stay close to Howland, and the Swan would be between Howland and Hawaii. The 3 ships communicated with Earhart via radio, but it was nothing like the sophistication we have now. As Earhart flew deeper into the Pacific, the communication problems only worsened. Radio waves and communications gaps. In 1887, a German physicist, Heinrich Hertz, placed a simple metal loop with a small gap across the room from a spark generator. When he created a spark on one side of the room, a tiny spark appeared in the gap of the loop on the other side, even though the 2 pieces of equipment weren't physically connected. Like throwing a rock into water, creating ripples that spread to other parts of the water. Electricity can also generate electromagnetic waves that travel through the air. These invisible waves, which we now refer to as radio waves, laid the foundation for radio communication, television, Wi-Fi, cell phones, and every other form of wireless technology we use today. When Earhart was circumnavigating the world in 1937, the technology was already in use for communication. Plans and ships used radio to transmit Morse code. Earhart had attached 5 radio antennas to the aircraft. The largest antenna, measuring 76 meters in length, was attached to the plane's rear. It could receive radio signals via the 400 or 500 kilohertz waves. The plane had 2 additional higher-frequency antennas for voice communications. One was for receiving signals, while the other transmitted radio waves. This was the one Earhart used to update the ground crew at Lae 4 hours after leaving. Earhart stated that her altitude was 7,000 feet and her speed was 140 knots. Then, she ended the message with, "Everything okay." She did not acknowledge the earlier warning of stronger headwinds. It is believed that she would have acknowledged the receipt of the messages if she received them. So, her receiving antenna could have been faulty or broken. It could also have fallen off entirely since it was located under the plane. 5 hours later, Earhart was expected to be close to the Ontario. The plan was for the Ontario to transmit repeated Morse code ends 10 minutes after each hour, but this directive did not reach the ship. So, Earhart listened for the codes, but nothing came. The Ontario crew stuck with the original plan, which was to start transmission only after getting a request from Earhart. However, they couldn't receive high-frequency signals or voice communication, which is why Earhart requested Morse code. But again, they didn't get this information. Since Earhart got no signal from the Ontario, she couldn't confirm if she was on course at that point in the journey. At this point, she had the options of turning back to Lae or forging on with the hope of finding the island. She went for the latter. More communication woes. Amelia Earhart's decision to continue the journey may have been influenced by the fact that she had other lifelines. The Itasca, which was stationed at Howland, could make up for the issues they've encountered so far. The ship was equipped with a radio for sending and receiving voice signals. They were available on multiple frequencies and would be transmitting Morse code every half hour. By 6:15 a.m. local time, the Itasca received its first message from Earhart. "Please take a bearing on 3105. We'll whistle into the mic. We are about 200 miles out," Earhart said, before she started whistling. The radio men on the Itasca did not understand what was going on. They were not expecting to take a bearing like Earhart suggested in her communication. They thought she would be doing that. Also, they could locate Earhart's radio direction with their equipment, but the frequency needed to be lower between 260 and 550 kilohertz. The higher frequency Earhart was using would scatter in numerous directions after reflecting off the ocean. So, they couldn't tell which direction the actual signal was coming from. Earhart waited. twisted the radio, and waited some more. She got only static. Howland would have been able to tell her direction with an Adcock antenna array, a system that pinpoints radio wave directions through their timing. However, the system required massive antennas that were not supplied to Howland when the runways were constructed. The only high-frequency radio waves locator was a portable version, which one of the operators carried. Sadly, the transmission from Earhart didn't last long enough for the device to take a bearing on the plane. When Earhart transmitted more signals, the operator missed a large chunk of them because they were conserving the device's energy. Earhart sent another message asking the Itasca to take another bearing and report in 30 minutes. But this would be outdated due to the time zone difference between the Itasca and the Electra. Earhart's Lockheed Electra was using Greenwich Civil Time, while the Itasca had clocks on the GCT minus 11.5 hours. Even Howland Island was using an entirely different time zone from the others. While it was 6:15 p.m. in the Electra, the Itasca's time was 6:45 a.m. So, when Earhart asked for a bearing at 6:30 p.m., saying on the half hour, the Itasca crew thought she meant 7:30 a.m., which was 45 minutes away. Static and bouncy signals. The longest antenna, which transmitted Morse code using lower frequencies, could have been used to communicate with the Itasca. But neither Earhart nor Noonan knew Morse code. This was why the antenna was also removed after the other navigator, Harry Manning, who understood Morse code, departed the project. Hence, the Itasca couldn't take a bearing on the plane. If Earhart wanted to take a bearing on the Itasca, her loop antenna could do the job if she had the right frequency for the Itasca. The ship crew had asked Earhart to choose a frequency for their broadcast. Since she wasn't sure, she consulted a radio expert who suggested Morse code A at 750. The expert was referring to signals at 750 meters, or 400 kilohertz. Earhart, on the other hand, made a mistake while telling the Itasca crew about the frequency. She told them 7,500 kilohertz, which meant that they couldn't communicate. Although she added that, if frequencies mentioned unsuitable, inform me, a correction was never made. Strangely, Commander Thompson on the Itasca knew about the issues with the frequencies. He was aware that the Electra had limited direction-finding ability, as informed by the San Francisco Division of the Coast Guard and Earhart's husband, George Putnam. He ignored mentioning the discrepancy to Earhart because he thought she knew more about her plane than anyone else. When Earhart asked about the suitability of the frequency, they assumed she was referring to the Itasca and simply stated that they could pick up a signal from any frequency Earhart broadcast. The Coast Guard attempted to persuade the commander to inform Earhart, but he felt it wasn't his responsibility to do so. By 7:42 a.m., a small glimmer of hope came alive when Earhart sent another message. You could tell that she was getting frustrated. Her voice was so loud that the men of the Itasca ran above deck to see if they could find her close by. We must be on you, but cannot see you. But gas is running low. Been unable to reach you by radio. We are flying at 1,000 feet. Unfortunately, the Itasca still couldn't connect. The portable direction finder's battery had been depleted at this stage. Earhart's voice never registered on the device, and hence, they couldn't take a bearing. 10 minutes later, Earhart's voice came through again. We are circling but cannot hear you. Go ahead on 7,500. The crew on the Itasca sent A's on 7,500 kilohertz, but the frequency was too high, and it scattered the signal in all directions. Earhart and Noonan received the signal in the plane. They turned on their direction finder, but could not locate the null. Without a minimum, Earhart couldn't locate the source of the signal. So, she sent another message to the Itasca. "We received your signals, but unable to get a minimum. Please take a bearing on us and answer with voice." Itasca's crew explained that, "Your signals received okay. It is impractical to take a bearing on your voice." They got no response. Since the receiving antenna was likely unavailable by now, Earhart never got any of their voice messages. Even if the Itasca sent messages at a lower frequency, Earhart wouldn't have received them since she had tuned her loop to 7,500 kilohertz. The final hours. The Itasca ship continued trying to establish a communication channel with Earhart without success. A few minutes before 9 a.m., she reached out again. "We are on the line, 157-337. We will repeat this on 6,210 kilohertz. We are running online, north and south." The radio operators on the Itasca would later describe her voice as frantic, strained, on the edge of complete panic. Some said she sounded like she was fighting back tears. Others said it was closer to a scream barely held in check. This woman, who had flown across oceans, who had stared down danger countless times without flinching, now sounded absolutely terrified. And then, silence. That was it. The last transmission anyone ever heard from Amelia Earhart. After that, her radio went dead. The Itasca kept calling out, hour after hour, but there was no answer. Somewhere out there in that massive expanse of blue, Amelia Earhart had vanished. It appeared Electra's fuel was finished, causing them to crash into the Pacific. The Itasca was joined by other Navy and Coast Guard ships and planes. It was the most extensive and most expensive search party ever organized by the U.S. at the time. They searched for 2 weeks without luck. No trace of the Electra, Earhart, or Noonan was ever found, even with the efforts of later search parties. The story of Earhart is one of missed opportunities. Every step of the way was a chance to try something else that could have saved her life. But one's decision-making can quickly get blurred when you're in those situations. Despite her inability to complete the journey, Amelia Earhart's name and that of her navigator, Fred Noonan, will remain etched in history for courage.